My name is Matthew Posner. Welcome to a dozen people who are joining us online from wherever you are in the world. I am standing physically in Polytechnique Montréal, and with another dozen people who are here to join us today for the IEEE Photonic Society Distinguished Lecture, our first of the year, with Dr. Daniel Renner of Atacama Optics and Electronics, but also a serial volunteer of the IEEE Photonic Society. I am delighted to welcome Daniel, who has been a friend and colleague for a number of years in the IEEE Photonic Society. We have served together on endeavors that's really look at engaging the industry, but also how does talent move into the workforce. And Daniel is joining us today from California and specifically Santa Barbara to tell us about his journey at a Photonic startup and a very personal account and a number of lessons which are being learned. So for those who are in the room, there's a coffee sheet going around. For those of you online, please grab your coffee and sit down and enjoy the talk wherever you are in the world. We will have Daniel for about an hour, and then the people online will have the exclusivity to be able to have a bit of networking. So without further ado, I'll be monitoring the chat. If you have any questions, please use that. We're going to ask you, if you're online, to just stay on mute and keep your cameras off. And Daniel, the floor is yours to take us through your very personal account of life at Photonic startup.
Thank you very much, Matt, for the introduction. Can we do it on display mode, maybe, or is that bigger?
Not sure how. That's the
if not, it's okay. It's big enough. View.
No, I'm not sure that was better. Sorry, everyone.
Don't worry.
Focus on contents. Let's see. Okay. Yeah. I think. Beg your pardon. We were hide presenter view. There we go.
Okay,
right.
That sounds good.
That's better for people in the room and better for people online. Daniel, the floor is yours. Thank you.
Thanks very much, Matt. And thank you, all of you, for being here. C'est un plaisir d'être ici à Montréal avec vous aujourd'hui. And that's the extent of my French. So sorry, we'll continue in English. But I had high school French, so you can imagine how that looks. So the reason we're here, or at least I'm here, is to tell you a little bit about what life at a photonic startup is. At a small company, and this comes through as a very personal account. I've actually, and we'll talk about this, I've been through a number of startups sequentially over the last 30-something years, and I've learned a thing or two. So the idea is to convey to you some of the things that I think are most important out of that experience, using me as sort of the experimentation subject. I mean, this is my experience. So as I say, we'll talk about my professional trajectory, and we will talk about things that I've learned other than the technology. Obviously, the photonic technology that is at the core of any photonic startup is key. That has to be novel. You have to bring some new product services to the market. But in addition to all you know about the technology, it's important to know about how to put a business plan together, a proposal together, how to budget, how to get funding, how to get money. That's not trivial under any circumstance. How to lead the team, program management, how to sell, et cetera, et cetera. And all of those factors actually at the end are all important. You really need to have a good understanding of all of them. But just as on the technical side, you're not going to do everything alone, on all the other aspects, you're not going to do it alone either. If you are going to form a startup and you are going to be the leader, you need to have an understanding of all of that. If you're going to join a startup, obviously a subset of that is sufficient. But it is very likely that if you join a startup, there will only be a few people, and you'll need to attack a lot of these areas simultaneously, and more than just the technical. Maybe a subset of that, but certainly more than one. So this is the beginning. We'll start my story from the beginning. That is me, and age about 4. And I'm from where that arrow points. I'm actually from the south of Chile, in South America. And I grew up there. And when I was about 22 or so, after finishing my first degree, this shows my trajectory. This is sort of south of Chile. I then studied in Santiago. Then actually I went to England, to Cambridge, where I got a PhD in what was then called optoelectronics. The term photonics hadn't even been coined at that time. I'm really old, not that old, but oldish. And then I worked actually for an American company in England, ITT, and then crossed the Atlantic back again, back to the New World, and I worked in Texas, and then after that in California, where I've been since 1989. So that is way before you were all born. So I've been in California a long time, which is where I'm now. So this is the trajectory, as I mentioned, with a little bit more detail. So my first degree in the University of Chile, second degree, PhD, University of Cambridge. Then I worked for 2 large companies, and those are the ones shown in purple here. I worked for what was then the central research labs of ITT, which were called Standard Telecommunication Labs, Standard Telephone Labs, actually, originally. Then Rockwell, and then the sequence of small companies. The first small company I worked for was Tell, and then I got hooked on small companies. I was at Tell for about 8 years, and then, as I say, sequentially agility, Areas, Freedom, and now Atacama Optics, which is essentially myself. It's a consulting company. For about a year now, I stopped working for Freedom about a year ago, and for the last year, I've been, as Matt mentioned, working as a volunteer with the IEEE, and also consulting for several small businesses. And if we look at this list, the universities obviously are still there, and Atacama, the current company, is still there, but none of the others exist any longer. And I can tell you, and I can promise you, it's not my fault. None of them disappeared because I messed up. It's the reason I'm pointing this out is that the photonic world, financial world, business world, the high-tech world is very dynamic. Things are constantly changing. Companies are created, companies are purchased, bought, acquired, merge, go broke. All of those things happen all the time. And one important thing for you to always think about is that all of these things are happening around you. Sort of, you might be working in a company that suddenly merges with another one. And you might have had something in connection with that to do with that, or maybe not. But either way, if as a result of the merging of the 2 companies, your situation changes, has nothing to do with you. It's basically the background, which is in constant change. And if you, so the lesson here, what is important is to keep your own personal vision of what you want to be and where you want to go, and pursue that relentlessly, irrespective of what's happening around you. Sometimes what happens around you might sort of be sometimes sort of it's a jumping board. It helps you to get to wherever you want. Sometimes actually can be a barrier. But if it becomes a barrier, the world is large. There's plenty of other opportunities within photonics for you to continue your path wherever you want to go. And that's essentially what happened to me. In a way, I pursued my vision, but at the same time, that vision changed as different roads opened up. I mean, what I ended up doing, I'm sort of a business development person in a startup. If you would have asked me, what is that, when I finished my PhD, I wouldn't even have known that something like that existed. So I ended up doing something which I love, actually. It's fascinating. I enjoyed it tremendously. But my life took me there. I had no clue that. So gradually, the vision changed. So, as I say, I started working at STL, and that shows the buildings at the time, which, as I said, actually not even the buildings exist any longer. They were demolished. Actually, I've been told actually the site is used now as a data center, which I think it's fitting to the times. The photograph on the right is Charles Keo working at STL. And actually, that was before I joined STL. I'm old, but not that old. He was working there before I joined. But for those of you that know, that are involved, actually, Charles Keo got the Nobel Prize about, I guess, 10 years ago or so, for being the first person that worked on optical fibers as a means to communicate. So actually, fiber optics as a communications mean was born at STL. So when I joined, which was about 15 years later, it was a place that already had a very strong history of working in photonic devices and fiber optics and so on and so forth. And I learned a lot there. It was an incredibly good place where to learn. I was incredibly lucky of what my first job was. And as you can see, I mean, the topic of the talk is about startups, and this was not a startup. The first two companies I worked for were large companies. But what I learned there, and as we'll see, is relevant also to startups, which is the central point of the conversation this morning. And my first job, so this is my first employer and my first actual job, was joining a team. I was small. I mean, I'm a starting engineer. I don't want to take any credit here for anything. I was kind of the last guy in the line of a team of about 35 people, developing lasers for TAT-8, which was the first fiber optic transatlantic cable that was deployed. Before that, it was copper. And so people realized, well, fiber optics obviously can carry a lot more information. We should use fiber optics to carry information flow from Europe to North America and vice versa. And that was the 8th transatlantic. The previous 7 had been copper. So that 8 was the first fiber laser. And I was in the team that was developing the first lasers, which were at 1.3 micron wavelength, to be deployed. And the cable system was designed to operate for 25 years. So reliability was a major concern. We had redundant lasers, actually, but even so, each laser was tested infinitely. And the cable actually operated for 22 years. And in the 22nd year, it was pulled out of the ocean, not because it failed. It did not fail. But after 22 years, the capacity of the laser of the system, of the fiber system, became negligible compared to other fiber systems. So you might be surprised, but this revolution, the first fiber cable crossing the Atlantic that was carrying a lot more information than any copper cable, was operating at the phenomenal speed of 44 megabit per second. So that was the volume of information that was carried across the Atlantic. That's about the same or less than what you get at your home today. So by that time, 22 years later, there were systems obviously that were carrying multi-gigabit. So what do you care about 44 megabit? There was no point in operating the system any longer. In 22 years, it became obsolete before its actually planned operating lifetime, and it was pulled out of the ocean. And actually, a section of the cable, which is shown on the right, is in display at the Science Museum in London. And this is actually me looking at that piece of cable. Actually, I had never seen the cable before. We worked on the lasers. I never saw the cable. The other guys were working on the cable. But wondering, what does this mean, that kind of this piece of cable that in some small way I was associated with is now in a museum. And the only conclusion that I could get to is that basically I'm old, such that a piece of what I was involved with is now in a museum. So I was lucky that that was my first job, and this is actually the team that, as I said, we're about 35 people. So where is Daniel? Where is Waldo? So I'm here. At some point, I didn't have gray hair. So that is a team, and sort of important lesson number one is that industrial product development is a team effort. As you can see, there were 35 people working on this. So in this, and this is my experience, I don't know if this is your experience, but at least my experience, and I can say of many other people that I've talked to, your education, if you want, in university, particularly as a postgraduate student, tends to be relatively solitary. I mean, not that you're a recluse or anything like that. I mean, you're talking to a lot of people, but your work you're doing alone. And in general, again, this is changing now, but in general, you really don't get a lot of training on how to interact. And again, I mean, we're all social, we all know how to talk to other people, but how to professionally interact with other people, how to work in a team, in a development team, how to plan work, and so on and so forth is something that at least I had to learn on the go. Most people learn on the go. And okay, not bad. You know, things didn't work out so badly, but I personally, at least, I think it's something that maybe could be done a little bit better, preparing students to work in an industrial environment where I would say almost never, I wouldn't say never say never, but almost never you're working alone. You're always working as part of a team that has a major role. So in that sense, working in industrial research or product development is more like a football team or basketball team rather than a tennis player. And so you need to know how to pass the ball to other people. And it also requires a broad range of technical specialties, not even talking about non-technical that I mentioned earlier. So typically there are people involved in device design, material science, as you know, mechanical design, reliability testing, and so on and so forth. And so there are people that are playing in different roles, just like in a football team, but they're sort of passing the ball to each other. So that's lesson number one. And lesson number two, this is lesson number two, but maybe it is one in the most important. I'm talking after 40-something years of work life, you should work with people that you like. That's very important. And this is something personal, of course, but from the point of view of the leadership of the company, the organization, it is a responsibility of the team leadership to foster a company culture where there is no fear, in which people can creatively enjoy their working hours. That's crucially important. And from your own personal point of view, develop your interpersonal skills, communicate openly. Communication in any group, whatever group you're talking about, in a class, in a married couple, and friends, is crucial. And it's never perfect. Sometimes not even good. But hopefully you can reach the level of good and without reaching the level of perfection. But you always have to strive to go in that direction. So within a product development team is the same thing. The largest complaint that people have in general is, we're not communicating. Why didn't you say that? And it's true. So it needs a very proactive sort of effort to make sure that the communication channels are there and you're working then with people that are enjoying what they're doing. So in this first job that I mentioned, where we developed the lasers for TAT-8, the cable was not laid across the ocean to start with. They did an early test. And the early test was sort of basically circling one of the Canary Islands and to see what happens. I mean, rather than spending all the effort and failing across the Atlantic, it's a great idea. Let's see what happens in a shorter path. And as expected, it failed. and it failed for a weird reason. It was bitten by sharks, and they found basically shark teeth in an area of the cable where it was sort of broken. So obviously it had been bitten by sharks. So this was the first cable, fiber optic cable, installed underwater. And copper cables were heavily armored because you need to shield them to protect them from electromagnetic interference. Now the thought was, well, this is fiber, there's no electromagnetic interference. They don't need to be shielded that much. Well, maybe they should have, and for other reasons. Now, the interesting thing is, as a result of this, and the cables were protected better, and they were laid through the Atlantic, and it was fine. But actually, I Googled shark biting sort of underwater cables, and I have never found that any other incident like this has been reported. So either the systems were improved to the point where the problem doesn't happen anymore, or this was just a crazy shark that happened to be there, and it was an isolated incident. Sorry? Yeah, that's true. There are less sharks around. So who knows? But the main point here, why I'm telling you this, is that early testing was very much part of the program. We were on a fast track, if you want. No one had. That was a time where all lasers actually were in gallium arsenide. No one, or indium phosphide lasers had been made, but it was the very beginnings of indium phosphide-based lasers. And certainly no one had used them in an underwater system. So a lot of early testing was crucial to be able to get there on time. And so, for example, early reliability stress of the diode lasers and early testing of new processes. Actually, that group there, we were the first to use laser welding in packaging. Today, photonic packaging uses laser welding, not in all cases, but in many cases, almost as a matter of routine. These were the first laser welded photonic packages ever. So testing the process early was very important, and so on in many other aspects. So in product development, early testing, I found, is crucial. Now, with time, some of this early testing, and particularly now, has been replaced by modeling. And I would like to add that modeling is a very useful tool to be able to predict without having to go through the whole process of actually building something, on at least narrowing the design space to an area where you're more likely to succeed. But beyond that, even today, I would say that with all the models we have, it's really very tough to predict exactly what's going to happen. So I would say a combination of both, narrowing the space with modeling and then actually building early something as soon as you can some kind of prototype is very important. So then from STL and in England, as I said, moved back to the New World, and I worked for another big company, Rockwell Collins in Texas. And Rockwell Collins was one of the dominant radio companies, actually, sort of throughout all the time from World War II to the 1980s, beginning of the 80s, both in radios for avionics and radios for communications. Before fiber optics, long distance communications over land were microwave. Basically, you went from tower to tower, and that was sort of a Rockwell Collins system. They could see the sort of revolution coming with fiber optics, and even though fiber optics was a totally different technology, but it was the same market that they were addressing. So they decided to move on to fiber optics, and that essentially was my opportunity and why sort of I joined the company, which was to form a group that would develop lasers and photodiodes for Rockwell fiber optic systems. And again, I'm extremely lucky. Luck is always important. You cannot rely on luck solely. You have to position yourself to make sure that luck can work. but then hopefully it will work. And so my second job was developing, as I say, lasers and photodiodes for landline communication systems. And this was the time, 1980s. I don't know if you've heard, again, this is before you were born, but you might have heard of the partition of the Bell companies. And essentially, there was a big monopoly in the United States that controlled long-distance communications, AT&T, Bell, and that was divided into several regional Bell operating companies that increased competition. Other companies also came into the competition fray. And that was a big boom for equipment manufacturers such as Rockwell. So there was a big competition with Western Electric, which was part of the old AT&T group, onto who would be the first company that would develop and sell a landline system operating over 1 gigabit per second. So again, this was a race. And this is something that in your future industrial experience, if you decide to go into industry, you will be subject many times. The opportunity window is kind of a certain time in the future. You estimate, okay, I need to be here in order to be able to sell this product and be the first one in the market. Otherwise, I will not. And instead of having, I don't know, whatever, half the market or maybe the full market initially, I'll be happy to have 10% of the market. So it's always a race, competition. Competition is vicious and at the same time a good thing. So it's something to be able, you have to learn how to survive that, be through that. It is possible to be able to compete without kind of totally killing yourself in that you don't want, but it is possible. And so we were in competition mainly with Western Electric and many other companies. And this is essentially the news that came out that actually Rockwell was the first company to deploy a system that was operating above a gigabit. So that's lesson number 4, that we were the underdogs. And many times the underdog wins. And typically it needs a very special combination of motivation, mission definition, talent of people, but it's possible to do. And that's essentially what a successful company can do over and over. So within Rockwell, actually, I had a dual, apparently contradictory role. On the one hand, as I say, I came to build a team that would develop lasers and photodiodes. But while the team was being built, we could not hold back the Rockwell system business. So in the interim, as a transition, Rockwell was buying lasers and photodiodes, actually mainly from Fujitsu and Hitachi. And I was also the guy then that had to define which laser and from whom Rockwell was. I mean, I didn't, again, define it alone. There was a group of people, but I was supposedly the expert. So I had this sort of apparently contradictory role. But obviously, I wanted to make everything. Sort of, what, you need a DFB? We're going to make it, of course. Oh, you need it 2 months from now. Well, maybe we should look outside and see who can supply a DFB. So that was my role. But in reality, there were, at the beginning, I felt it's contradictory. I had the natural instinct that would say, okay, we'll do it, no problem. We know how to do it. Well, it will take 2 years. Cannot wait 2 years? Well, kind of, all right, well, maybe we should buy it. So after a while, I realized that it was really a single role, which was to provide Rockwell with optoelectronic components that were appropriate to whatever was needed, whether we made it in-house or not. In business, obviously, the key goal is business. And in this case, the business was fiber optic systems business. And the photodiodes, the lasers, and so on were supportive. in general, components are to the system. You're at the sort of tail end of the supply chain. That's a totally different talk. We can talk some other time about what does it mean to be at the tail end. It's perfectly survivable again, but it's not very comfortable. But anyway, so I understood that we needed to look outside, and then the Rockwell 1 gigabit system used, as it came out, photodiodes that were made internally, and DFBs that were made by external suppliers initially, which were replaced after about a year and a half with internally made DFBs. So lesson number 5 is you should care deeply about your business, whatever the business is, which means caring about the interest of your customers and your customers' customers. So you should focus on what problem are you solving and not in the technology. This is something that as an engineer, actually I've fallen into this, so I'm talking for myself. Maybe you feel some commonality with this, but I would very easily fall in love with the technology. Wow, this is neat. I think kind of we all experience that. This technology is absolutely marvelous. But if you're in industry, that's okay. I mean, that's a wonderful feeling to feel that you're working on neat technology. But you have to always marry it to the need, to the customer solution that you're looking for. You cannot look at the two independently. In fact, as it happens in business, the solution is the dominant force. You cannot work in business just because something is neat. That might end up in somewhere good, but might not. So you need to look for the overlap, something that is of neat technology and there is a business case around it. So that's lesson number 6. It's dangerous to fall in love with the technology and lose sight of the business. And also, as you do this, realize you cannot do it all. What you should aim at doing is to identify what are the unique areas where you're offering something that no one else can offer and focus on that. Some companies, for example, have outsourced all of the manufacturing. They focus on design, and that's fine. If you're a unique designer, if you have ideas and ways of doing design that no one else has, and obviously then once you've developed it, have the IP to protect them, no problem. I mean, that's a business. And you outsource. That's a way, for example, where a lot of CMOS companies operate today. And the CMOS fab is billions of dollars of investment. And there are many, obviously, as you know, that offer this as a service. So there are many smaller companies that design particular ICs with very specific and unique specifications that then are fabricated in these common fabs, and that's perfectly okay. If your expertise is in 3.5, tends to happen more than in silicon, that kind of you have some unique capability in terms of semiconductor growth or processing, well, okay, that's for you to exploit. But then again, you can outsource some of the needs. At Freedom Photonics, for example, which is where I worked until about a year ago, we were in the 3.5 business, also Group 4 actually eventually, and that's how I got to meet Usama working on Group 4, and that was very exciting. So, but we designed photonic components, and we had no epi capability. We never went into kind of having an epi reactor. We designed the epi wafers, and we had all the guys that are around us grow. There are plenty of them that can grow the wafers, and that was very successful. At the same time, we did have processing capability, but through the nano fabrication facility that UCSB has in Santa Barbara. So we had our own people there operating the facility, but as soon as the process matured, typically we would send it also out to a fab. So the strengths, I would say, of Freedom were on the design side. We could design things that no one else could, or few could. And on the sales side, we had connections, our network in selling, which is something you shouldn't forget. It's important to have a capability of selling. So we could design and sell, and in that aspect, I think we were unique or very good. The rest, we did some, but it was okay to outsource. The seventh lesson is that, and this is something else that I think, and again, I'm talking about me. I came out of doing my PhD with a slightly distorted view of kind of what is product development, in the sense that as a PhD student, you're after a hero result. You got one device that worked in a certain way that you wanted, the lowest threshold in the world, the highest power in the world, the highest sensitivity in the world, whatever it is. And that's worth a paper, and you're famous, and whatever. And that's your kind of view. That's how your blinders blind you. But obviously, making one device from an industrial perspective is not a business either. You need to make it at a cost that allows a price that makes sense for the market. That rarely comes into the equation when you're a PhD. So if it has to have a certain cost, it has to have a certain yield, you need to make more than one. And you need to be able to make whatever the market needs. The market needs 1,000 a year, and the market needs 1,000,000 a year, whatever the number is. You need to have an appropriate way of making it such that you can make 1,000, you can make 1,000,000 at a cost that is business competitive. And in general, rule of thumb, and actually in the past, I would say actually that the time and effort for an individual to get to being able to make one takes you to the halfway point. I think that that's optimistic, actually. You spend a lot more from there to be able to make 1,000. So you're not even at the halfway point there. So again, it's a difference in mentality that I had to change my mentality after I started working. And it's something I think is good to understand before you get into industry. So we've talked about the large companies. Now, the startups. So these are the startups. Or tell. Actually, I don't know if you've ever heard of Tell, but it's a company that in the 90s, particularly, and then onto the, well, it still exists today as part of MCOR, was the leading company into cable TV, fiber optics for cable TV. And that was based on technology that was developed, and understanding that was developed for RF over fiber. Then agility. Agility was part of the bubble in sort of the late 1990s, year 2000. And we were basically developing widely tunable lasers, monolithic widely tunable lasers for WDM networks. WDM networks were coming then at the time. Basically, the thought was the internet is sort of starting and growing tremendously. So fiber optic capacity needs to be multiplied. The sort of common sort of word at the time was that the internet traffic was doubling every quarter. And obviously it was growing very fast, but it was nowhere close to doubling every quarter. It was doubling every 8, 10 months, maybe a year. So there was overspending. This happens also many times in industry. People got overstimulated and spent a lot of money. So agility was part of that, actually. In agility, we raised over $200 million to develop this component. That's a lot of money. A lot of money was wasted too. And the technology still exists. Actually, eventually, in 2004 or 5, JDSU bought agility, and this tunable laser technology is being used by JDSU, Lumentum, which kind of continued from JDSU even today. So the company doesn't exist, but the technology was good. It was just that it was ahead of its time. Then Arios had basically 2 lines, infrared imaging sensors and high power lasers. The high power lasers were fed then into miniature laser rangefinders. Really very unique, very low weight miniature laser rangefinders, essentially aiming at going into small UAVs. Then Freedom Photonics, which I mentioned about, and Freedom Photonics, we decided that we would develop several areas of technology as a means of stability to avoid going down with one. And now obviously that spreads your effort more widely. So it's a balance. How far do you spread and how many? So we had mainly high power lasers, PICs, high power photodiodes, and tunable lasers. And now, as I mentioned, Atacama, that's my consulting company. So it's worth talking a little bit. I mean, if you've noticed, most of the, except for Tel, all the other startups that have been involved are in the Santa Barbara area. Yeah. Okay. Sure. Why did I change? Good question. Very good question. So as you can see, I moved from 4 startups, and essentially the reason I changed from all of them, including Freedom, is very similar. All of them, well, of the 4, I had 3 successes and 1 failure. Agility was a failure. That's at the time of the bubble. Agility was eventually bought by JDSU. And as I say, the technology was good. The technology is being used, but the company was a failure. And why do I call it a failure? Because I mentioned earlier that the investment was $200 million, and JDSU bought the company for $50 million. So the investors got 25 cents on the dollar. That's a failure. So that's one failure. So I left because it was a failure. The other 3 were a success. So that's my record, 3-1, not so bad. And I left those 3 at the time when they were acquired by someone else, and they became a large company. So Freedom Photonics in April 2022 was bought by Luminar Technologies, which is a company that is involved with the automotive LiDAR business. We were working together with them, developing a high power 1550 laser. We were successful. We developed a diode laser that kind of made 10 watt out of a single diode at 1550. And so at that point, they said, well, maybe we should buy you. And we said, well, maybe you should make an offer. And after a long process, the offer wasn't very good initially, but anyway, to cut a long story short, we came together, and Luminar Technologies bought Freedom Photonics. So Freedom is now part of Luminar and supplies lasers internally for whatever Luminar needs, but also continues supplying externally. At that time, 2022, Freedom Photonics had about 55 employees. Luminar had 1,000. And every time this happens, suddenly we go, okay, I'm in a company with 55 people, and suddenly I'm in a company with 1,000 people. I take it very openly with wide eyes. I say, okay, this time maybe I'll like it. And a few months later, the same happens. So maybe I don't like it. And I've worked with large companies initially, as I mentioned, but since 1991, which is now 30-something years, I've only been with small companies, and by character, by nature, by who I am, I just cannot work in a large company. So the company was bought in 2022. A year later, well, we worked this out before. After a few months, I said, hey, maybe we should find a different arrangement here. I'll transfer everything to other people, but I would like to get out. So. No. No, that came, I mean, we were working with, say, with Luminar, and we didn't have any specific plans of selling the company. Obviously, we had rough idea. Again, it's important to have a vision. The vision was that there are many ways to exit, but there would be an exit at some point, but not necessarily at that time. So, as mentioned, I don't know, are there any other questions for now related to this or anything else? We can talk more about it then. Yeah, we can do it later. Yeah, let's finish. Yeah. Okay, we're going to wait until the end. So, and the fact that all of these startups are in, say, the Santa Barbara area is no coincidence. There is a micro sort of ecosystem in Santa Barbara, and that is important for any high tech. I mean, why is there a Silicon Valley? I mean, there's a lot of kind of interconnections there. In Santa Barbara, there is a mini Silicon Valley regarding photonics, if you want. It's sometimes referred to as the infrared corridor. And this is because UCSB is very strong, has a very strong presence in photonics, from which new ideas come out. Students finish their PhD and they come out with their ideas and they want to start a company. Engineers are being trained and they can join the company. The nanofabrication facility, which I mentioned, is there, which is a huge investment. And so being close to the nanofabrication facility is a must. Otherwise, as a small company, it's literally impossible to, and as a small company, to have all that equipment. But if you have access and you can rent it, and in UCSB, it can be accessed at $142 the hour, which is very cost effective. So all of these things lead to the formation of an ecosystem, which is really important. Funding a startup, there are many ways on how to fund a startup. Or tell, for example, was bootstrap funded. Bootstrap means that essentially you're growing out of your own income. You're generating you're getting programs, you're selling product, whatever it is, but your income makes you reinvest the profit, and you grow, you get more programs, you grow of what you're doing. And in this sense, for this, in the United States, there is a program called the SBIR program, Small Business Innovation Research. I'm sure that in Canada, there must be something similar. And this is a fundamental means to raising funding for small businesses in high tech in the United States. Or tell was bootstrap funded and then received private investment after about 6 years. That's another source. There are groups of private investors, so-called angel investors, corporations, customers that might want to invest, and so on. Agility Communications was venture capital funded. This means, in general, larger capital infusions than in bootstrapping. You can grow faster. But then company control many times can become an issue. Then areas and freedom were bootstrap funded as well. And this is not to say that there is one better way of doing it. These are all different ways that different companies use. It depends on the nature of the company. It depends on your nature, what you prefer, and any of these can be applied. There are pros and cons in all of these ways. So this describes the SBIR program in the United States. As I say, in Canada, there must be something similar, but typically what happens in the States is that all government agencies that have a research budget, so the Department of Defense, Department of Energy, NASA, Department of Agriculture, et cetera, they all have to spend, I think the number is around 4%. They have to allocate 4% of their budget to the SBIR program, which is limited to small companies. Large companies cannot bid on that. And a small company is defined as having no more than 500 employees. So some of these small companies are, I mean, at 500, you're already, in my opinion, fairly large. So, but anyway, so typically people or companies that would be performing here have anywhere between 1 and a few hundred employees. So in terms of an ecosystem, lesson number 8 is that not only you cannot work entirely by yourself, you need a team internally to the company, you need a larger team. You need a team outside of you. You need an ecosystem. So for the startup, for example, as we already mentioned, you need to have an accessible wafer fab. You need government funding. You need private funding. You need trained personnel. You need universities, research labs nearby that can provide additional resources and things like that, which we already talked about. But there is even more. You need sales channels. You need fab facilities that you can outsource. And so it's a whole solar system around you, without which it is really very hard, if at all possible, to start a company. Lesson number 9 is that you need a plan that covers both business and technical aspects. Now, a plan is there to be changed as soon as you start. But still, as I said, it's important to have a vision. That's the purpose of the plan. But it needs to be flexible, because as soon as you start executing, you'll find out that that you need to change. I found, I don't know, about 15, 20 years ago, I came across the Heilmeyer questions, or they're also called Heilmeyer Catechism. Mr. Heilmeyer was a director of DARPA many years ago, many decades ago, and he posed a number of questions that he wanted for every internal proposal at DARPA to address. And I think these questions are very important, not only as a DARPA proposal, but you should answer them for any proposal. And the business plan is essentially a proposal. It's a type of proposal. And so here I've changed them a little bit, what the questions are. And I believe this will be accessible in the IEEE website afterwards. And if not, I can send you these slides if you want. I'm not going to go into every detail of this. But essentially, you need to have clear objectives that those questions address, an approach on how you're going to address those objectives, what are the resources involved, how long will it take, and what are the risks and opportunities. And essentially, those 5 things are the key elements of, as I say, any proposal. And the lesson number 10 is, if you're interested in working in industry, in either forming a startup or joining a startup or joining a large company, whatever you want, dare to act. I mean, what are you going to lose and what are you going to gain? So follow your passion. Do what your passion is driving you to do. And if you join a startup, I think you'll have an opportunity to look at many other aspects other than the technical. You'll look at, as I said, financing, proposal preparation, psychology. Again, not that I'm a psychologist, but I had to learn a question or two, and you'll get to learn about that. Many times I still say that problems in a high-tech company are 20% technical and 80% human, and that is very true. So you need to have the tools on how to at least try to address the human problems. So thank you very much, and it's been a pleasure being with you, and it's great to be here.